Scientific research is not really very complicated, at least in an idealized form. It is basically just consistently using common sense. This should become clear as I explain how research is done in psychology. My name is Jouni Vilkka, and this is my channel, TFF Teacher from Finland. Don't forget to subscribe and click the thumbs up button. The typical research process in psychology follows the same common structure as any other field of science. I've divided it to 9 steps as follows. First, the research problem or question has to be delineated. It is important to narrow it down to a workable chunk. A very specific question is easier and faster to answer than a broad one. It is necessary for the question to be specific so that the way to answer it can be figured out. A vague question that could be interpreted in many ways is not very useful. For example, a researcher might be interested in the possible influence of stress on performance. They have to turn that into a question, such as, does increase in pressure have an effect on performance on tasks requiring working memory and deductive ability? For a second example, a researcher could be interested in the influence of money on happiness. They might ask, does it matter whether the money is being used for oneself or for the benefit of others? 2. The research has to start somewhere, and usually it is with a working theory that is put to the test. A hypothesis is formed, deduced from the theory. A hypothesis is basically a prediction of what should happen if the theory is correct. The result of the research should then either tend to confirm or disconfirm the theory, based on what actually does occur. This is how theories get tested. To continue the earlier example about the effects of stress on performance, the researcher could hypothesize that increasing pressure will impair the subject's functioning in tasks requiring working memory and deduction. In the second example, the researcher could reward the subjects with money as part of the experiment, but also give them the option to give the money for a good cause. The hypothesis could be that those who choose to donate the money will report higher levels of happiness than those who choose to keep the money. 3. The next step is to choose the right research methods. It could be as simple as having people submit their answers to an online form, then downloading the data for processing. Or perhaps simple, so-called naturalistic observations in an everyday situation is enough, or perhaps some type of experiment is required. 4. To collect data, a sample of test subjects is usually required. How that sample is selected is very important, as of course is the method of gathering the data. The research design appropriate for the study has to be chosen. In the case of an experimental study, the concepts of single-blind study and double-blind study are important. Both are about limiting knowledge that could influence the analysis. The first is a study where the researcher analyzes something like the brains of chickens or some homeopathic substance, for example. She is blinded so that she does not know which of the subjects she is analyzing are the ones that have undergone the relevant manipulation, so that her analysis will not be biased by that information. A double-blind study is easiest to explain in the context of medicine, with patients receiving the treatment that is being studied. It could be a type of psychotherapy or a psychoactive drug, for example. Because the possible effects of the treatment have to be compared to something, the patients have to be divided into a test group and a control group. Those in the control group receive some other treatment, if available, or just a fake treatment, such as a pill that has no active ingredients in it. It is sometimes called a placebo, but technically any treatment can have a placebo effect, meaning that the patients will experience some improvement compared to not receiving any treatment. It is also possible that they experience a nocebo effect, a decline in health, but it is not as common. Because there usually is some improvement even without real effective treatment being given, it is important to compare the effect of the new treatment in the test group to this placebo or control group, and not just to a group of untreated subjects. There are also ethical reasons to give the patients at least some treatment if any exists, and if any exists, it probably has to be used. What makes this a double-blinded study is that the patients, as well as those giving the treatment, are both blinded. This should always be done when testing a treatment because it is not enough to blind the patient. If the person giving the treatment actually knows whether they are giving what is assumed to be an effective treatment or just a placebo, this information will find a way to leak through unintentional body language and other such ways, so that the patient will then also, at least at some level, become aware of this, and it will affect their experience. In short, when dealing with human subjects, studies should always be double-blinded. Single-blind studies should only be used when dealing with inanimate objects, such as substances that must be analyzed. 5. Actually conducting the study, collecting the data. The decisions have been made, so unless something unexpected happens during the study, this phase should be fairly straightforward. Of course, an unexpected occurrence could force the researcher back to the drawing board. 6. Analyzing the data. Typically, statistical analysis to see if there's a correlation between the variables as expected, and if so, how significant it is and how strong. This might not require a lot of math, but one has to know the basics of how to use the statistics programs like SPSS. In the case of an experiment where the test subjects have been divided into a test group and a control group, the possible effects on each group have to be compared to each other. To be considered a useful medicine, a drug should improve the health of the recipients significantly more than a placebo, for example. 7. Interpreting the results. The numbers alone don't mean much. They have to be understood in the right context. What conclusions can actually be drawn from the results, if any? There are probably some limitations for making claims based on the study that the researcher must be aware of. For example, a drug trial might find a significant improvement in the general mood of the subjects taking it, and so the drug might seem to be useful. But at the same time, those taking it might be suffering from adverse effects so harmful that the drug cannot be recommended for use. An experiment should be relevant from a theoretical point of view. It should lend support to or challenge a theory, for example. If the theory in question is considered extraordinary, the requirements for the experiment will reflect that. An extraordinary claim is a kind of a scientific way to understate the fact that, if true, the theory would overthrow the scientific consensus on the issue, or even the scientific worldview more broadly. One type of study is called a meta-analysis. Instead of conducting an experiment, it looks at all previous relevant research into the same thing. The point is to look at the big picture and see what the general consensus of all the data is. This type of research has problems of its own, such as the infamous file drawer problem, where so-called null results tend to not get published, which tends to bias meta-analysis. Such things have to be taken into consideration when interpreting the results of the analysis. 8. The study has to be written up into an article and sent for publication in a proper scientific journal. It is not easy to get published in one. First, the editor might not even accept the article, but even if they do, it will have to go through peer review. Usually that is done anonymously, as much as possible anyway, so that the reviewer or reviewers don't know who submitted the paper and the author doesn't know who the reviewers are. The peers might reject the paper or offer suggestions for improvement. This way the paper can go back and forth a few times before getting published. It makes the process slow, but the idea is to make sure the quality of an article, and thus the whole publication, is good. There are predatory journals that do not actually use peer review, but require a payment from the author. They will publish anything, but since the publication is actually trash, it would be better to not spend money to get published that way. It may be tempting to do so because it's a sure way to get published, but it won't really improve one's reputation and it won't count for the citation index. Publications in poor quality journals can be used to lengthen one's list of publications, but anyone looking through that list might recognize or find out what kind of journals are on there, so that is probably not a good idea in the long run after all. 9. Finally, once the article gets published, there will be critical public discussion about it. Other researchers may of course ignore the article, which is not good, or they might cite it favorably. Or they might show all the mistakes the author has made, rendering their work useless, after all. Experts have to read lots of articles in their own fields, which is how they gain a good understanding of the current situation and why it makes sense to trust experts more than other people. Anyone can read an article or even a book, but without a broader grasp on the subject being discussed, they may not be aware of how the work has been received and critically examined by the expert. They may become convinced by what is essentially really poor quality research. In the next videos, I will discuss types of psychological research and how data is collected and analyzed. I hope to see you back on my channel then. Bye for now. If you wish to support my channel, please click thumbs up, subscribe and share my videos. Any comments on the videos would also be welcome.